Go 6.4 is another set of triangle similarity theorems, and these acronyms here are going to seem very familiar to us because these are the same letter combinations that we've seen in triangle congruence, right? But this time we're not going to be using them to show that triangles are congruent. However, this time we're going to show that triangles are similar. Just like in the previous video, we talked about angle-angle similarity. Here are two additional ways to prove that triangles are similar, which means that their angles are congruent and they are proportionate in terms of their side lengths. So the SSS Similarity Theorem states that if the corresponding side lengths of two triangles are proportional, then the triangles are similar. And that has to do with AB here being related to RS and so on and so forth. This isn't any different than any other corresponding parts that we've been talking about previously. So really what I like to do is I like to check all three sets of ratios. The first ratio would be AB to RS, and then BC to ST, and then CA to TR. And if we can show that all the ratios are the same, then we show that the triangle side lengths are proportionate to each other. So here's a question that talks about the SSS Similarity Theorem. This says, is either triangle DEF or triangle GHJ similar to triangle ABC? So we have a lot of letters going on there. Basically, they're asking us which of these two on the right are similar to the larger one on the left. And what's nice is they have the red going to the red, I think. Yeah, they have the red going to the red, green to green, and blue to blue. So they corresponded their parts with colors. So we really just have to check the ratios here. 8 to 6 is equal to 12 to 9, which is equal to 16 over 12, right? So I'm checking to see if this triangle DEF is similar to the original one, and then we'll check this one over here. But you're gonna notice I'll use question marks above my equal signs, and I might have done this once before, but this is because we don't know if they're equal. We're trying to determine that, right? So we throw some question marks in there, and so we'll reduce this and we'll determine if these two triangles that are next to each other are similar. This becomes 4/3, okay? This becomes 4/3, and divide these by 4. This also becomes 4/3. So in fact, we have that the first two triangles here are similar. And just real quick, I'll get red because this one's not going to work. Let's show, we're going to go 8 to 8. Okay, so I can already see an issue here because that's a 1. 12 to 10 is equal to 16 to 16. So it looks like two of these have a 1-to-1 ratio, except this middle ratio. And so again, we put our question mark here because we don't know if it's true or not. This is a 1. This reduces to 6/5, which is close to 1, but it's not 1. And that's 1. So this we would say is not similar. These are not equal. However, this is equal, so the ratio here is nice and clean. The ratio between the first and the third, not so much. That's it. It's just about checking ratios. And if we can show that this side lengths have this relationship, then we can say that the corresponding angles are definitely congruent. And the side lengths are proportionate. Okay, so using the SSS Similarity Postulate here, let's throw some algebra in here because that's typically what we like to do, just to sharpen our algebra skills for next year. So we're going to match up corresponding parts. AB are the first two letters. DE are the first two letters. Again, I've said this before. Use the letters here. Don't just rely on the picture. Because, yeah, 4 belongs to 12 in terms of correspondence, but that's not always the case. A and B come first. D and E come first. So that does happen here. We have 4 over 12. All right, is equal to, let's go, x minus 1, BC, EF, x minus 1 over 18. And then that's going to be equal to 8 over 3 times the quantity x plus 1. Okay, so we got a lot going on here. Find the value of x that makes this true. What we really should do is reduce this first and foremost. That's a third. Okay, I'm going to set that equal to, you know what, I'm going to take this one and set it equal to a third as well. And we'll solve both of them just to make sure that we get the correct value for x that makes this true. How do we solve a proportion? We cross multiply, so that's 18 is equal to 3x minus 3. Right, add 3 to both sides, 3x is equal to 21. Divide by 3x is 7 here. Similarly, over here, I'll cross multiply and get 24 is equal to 3x plus 3. Subtract 3, divide by 3, x is 7. So yeah, in fact, x has to be equal to 7 in order for these things to be proportionate. And just double check both of them for sure. We want to make sure we grab that correct value for x. SSS postulate is very easy. It just has to do with the side lengths creating proportions. That's all. SAS is another triangle similarity theorem. This one says that if an angle of one triangle is congruent to one angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. Okay, so they're referring to this length xz, okay, xz being, they're referring to xz corresponding to MP, and xy corresponding to mn, and those are the sides that are including the angle, right? That means they're surrounding the angle. We're not talking about this side length and this side length because they're not. They're across from the angle, right? So the words here are very important. All right, so with that said, let's do some practice problems. The angles have to be the same, and the including sides have to be proportionate. All right, take a look at this diagram here. We have SAS similarity. So you're building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so it is similar to the left end using the angle measure and length shown? Basically, this is just asking if these things are similar or not. All right, so let's just extract the geometry from this picture and talk about yes or no, are they similar or not? So 6, 53, and 10 corresponds with 9, 53, and 15. So the first piece of criteria is, yeah, they have to have an angle that's the same. Okay. All right, so they have the same angle, different size triangles. We're going to compare the ratios. 6 to 9 is equal to question mark 10 to 15. All right, and when we simplify, we got to determine if this is true or not. 6 over 9 is 2/3. 10 over 15 is also 2/3. So what we would say is yes, these things are similar, and the third and final side length right here would also have to be a 3:2 ratio, big to small, whatever those numbers are. Okay, and that's really it. So now, in summary, we have 3 triangle similarity theorems, just like we had a collection of 5 triangle congruence theorems, and these are going to help us just simply answer yes or no questions and to write proofs. Are they similar? Yes or no, using either angle-angle, side-side-side, or a combination, which is side-angle-side. Again, I'll upload some practice determining and using these 3 theorems. All right, so everybody keep up the good work.